So with variation, we also have what's called inverse variation. So if we see a statement similar to this one here, that if y is inversely proportional to x, or we might see varies inversely to x, then we get the equation that is slightly different than the last one. We're instead going to have y equal to k over x. So instead of k and x being multiplied, k is being divided by x, where still k is our variation constant. With this, when it's inversely proportional or varies inversely, that essentially means that the two variables are working opposite of each other. That as our x increases, it gets very large values. The y is getting very small, it's getting very close to 0. And then as our y increases, if we want a very large y value, then our x is getting very small. It's getting very close to 0. So they're kind of going in the opposite direction of each other. So now, this first example that we have here is that the number of potential buyers for a house in a city in California is inversely proportional to the price of the house. And we are also then told that a house that costs $500,000 will have 200 potential buyers. And we want to write a model that will tell us the number of potential buyers B for a house with a price P in thousands of dollars. This part means that we want the model, the variable P, to be written in thousands, so I don't have to add on all the extra zeros to my $500,000 up above. Okay, so we were told that the number of potential buyers is inversely proportional to the price. So our equation that we're going to start with is buyers B is equal to K divided by the price P. And now we can use our data that when it costs $500,000, so P is equal to $500,000, we will have 200 potential buyers. So I am going to have 200 buyers is equal to K over 500. And now I want to solve this for K. Well, K is being divided by 500, so the opposite of that is multiply by 500. And I need to do that to the left side as well. So this is going to then give us that K is equal to 500 times 200, which is 100,000. So now I can go back to my starting equation that I wrote, B equal to K over P, and replace K with 100,000. So we have B equal to 100,000 over P. And now I can use this model to answer the next question. If a house price is $2 million, which thankfully we were already told is 2,000 $100,000. What would be the number of potential buyers? Well, my P in my model is the number of thousands of dollars. So I'm going to let P be 2,000 and then evaluate what B is. So our number of buyers is equal to 100,000 over 2,000. And then that should then give us that B is equal to 50. So we have 50 potential buyers for this house. And then a lot of times it's helpful to think through our answer to make sure it makes sense. We were told that these two things varies inversely from each other. They're inversely proportional. So if the price of the house goes up, the number of buyers should be going down because there's going to be less people that can afford it. So when we started with that house that cost $500,000 and it had 200 potential buyers, well, now if we then go ahead and look at a different house that costs $2 million, the number of buyers should be less. And that's what we got. We got a smaller amount of buyers because the cost went up. Okay. We also have that our examples, they can vary inversely to some power of x, similar to the direct one. We're not going to go through the definition because it's just very similar, but instead we're just going to go straight into the example of an nth power inverse variation. So here on this example, we have that the loudness L of a sound measured in decibels is inversely proportional to the square of the distance, d squared, in feet from the sound source. And then we are also told if a person is 15 feet from a leaf blower, the sound is 100 decibels. So now we want to write our model for this and to use the given information that we have to evaluate what K is. So to start, we have that the loudness L is inversely proportional to the square of the distance. So that means L is equal to K divided by our distance squared. And now let's use our data to evaluate K. We have that if they're 15 feet from the leaf blower, so if distance is equal to 15, then the loudness, the decibels, is equal to 100. So our loudness L is 100, and that's equal to K over 15 squared. And now I want to evaluate what K is. K is being divided by 15 squared, so we can just multiply both sides of our equation by 15 squared. So now that's going to give us that K is equal to 15 squared times 100, which that should then give you 22,500. So now let's go back to our original equation and replace K with 22,500. So L is equal to 22,500 over the distance squared. And now we can answer some questions about this. How loud is the leaf blower if a person is 45 feet away? So we're going to be solving for L, the loudness, and we need to replace the distance with 45. So L is equal to 22,500 over 45 squared. And now that we can evaluate, and if I round to the nearest tenth of a decibel, this should give us 11.1 decibels for our answer. And then lastly, we have if the loudness of a leaf blower is 900 decibels, how far is the person from the leaf blower? So now we have been given the loudness L, and we need to solve for the distance D. So our equation is going to be 900 equal to K, or sorry, not K, we know what K is, equal to 22,500 over the distance squared. And now we need to figure out what D is. The issue with this to start off is that our distance variable here, D, that we're trying to solve for, is in the denominator of a fraction. We need it not to be in the denominator of the fraction, so we could multiply both sides of our equation by D squared just to get it so that's in the numerator instead on the other side. Another method that we could do that is usually more easier for students to understand is to think about this as like a proportion. If I put the 900 over 1, now this looks like a proportion that I can evaluate here or to start solving. And we can use the cross multiply method. So if we cross multiply this, this is going to give us that 900 D squared is equal to 22,500 times 1, which is just 22,500. So now we need to solve for D. We look at our D, it's being squared, and then it's being multiplied by 900. So that means we need to first divide both sides of the equation by 900. So this gives us that the distance squared is equal to 22,500 over 900, which that evaluates to be 25. And now we need to undo the squared. To undo that, we can just take the square root, and we need to then do that on both sides of our equation. So this gives us that the distance is equal to the square root of 25, which is just 5. And our distance here is in the unit of feet. So if they have a loudness of 900 decibels, then that means they're very close to the leaf blower. They're only 5 feet away.